So how do you put clients into the relevant VLANs, such as on this port and this port? Notice that on switch 3, this switch here, that all ports are in VLAN 1, the default VLAN. Simply having the VLANs in the VLAN database doesn't mean that ports are put into the relevant VLANs. You still have to configure your VLANs manually. You still have to do commands such as the following to create your VLANs. So create the relevant VLANs as required. And in this example, VLAN 10 was already created, but there's no harm typing that command again. So there are our relevant VLANs, VLANs 1 to 11. Previously, this client switch only knew about 10 and 11, but now the other VLANs have been synchronized to the switch. But notice interface gigabit 01 is configured to use dynamic auto, but the current operational mode is static access. The port is in VLAN 1, but in this example it should be in VLAN 10. We still have to go onto the interfaces and type switch port mode access, which is a default command, and then switch port access VLAN and specify the relevant VLAN. So now show interface gigabit 01 switch port shows us that this port is in VLAN 10. So there's the command, gigabit 01 is in VLAN 10. So the point to remember is that VTP doesn't put interfaces into the relevant VLANs. You still got to configure the ports with the relevant mode. So if you want trunks, you have to manually configure them or use DTP. And access ports have to be configured with the relevant VLANs. VTP, once again, allows for the synchronization of VLAN database information. It doesn't put ports into the relevant VLANs. So I'll start up these two routers just to prove that the network works properly. And then I'll show you an issue where we delete a VLAN on one of the switches and show you how it breaks the network. So on router 1, interface F0/0, we'll give this router an IP address of 10.10.10.1. And on router 2, interface F0/0, no shut, IP address 10.10.10.2. So it should be able to ping router 1 if our network is set up correctly, and it can, as you can see there. Router 1 should be able to ping router 2, and it can. So debug IP ICMP on the left-hand router will allow us to see that the pings do arrive on this side, and there you go. Now, let's do a continuous ping. So I'll repeat this 10,000 times. So router 1 is pinging router 2, and the pings are succeeding. But what I'll do now is go to one of the switches, let's say switch 2, and I will remove VLAN 10 from the VLAN database. And let's see what happens. Notice on switch 2, I removed VLAN 10 from the database, and pings are now starting to fail between router 1 and router 2. So show VLAN brief. VLAN 10 has been removed from the VLAN database of switch 2, and on switch 3, where the router is connected, VLAN 10 has been removed from the database. Show interface gigabit 01. That's this interface, which should be in VLAN 10. It's showing as up, so the port is connected. Show interface gigabit 01 switch port. Notice we're told that VLAN 10 is inactive. There's a problem on this port. The port is configured as an access port in VLAN 10, but VLAN 10 doesn't exist in the VLAN database. So the port is essentially non-operational. On a physical switch, it might show as error disabled. This is one of the major problems with VTP. If you added a switch to the topology and that switch had the wrong VLAN database, so as an example, VLAN 11 didn't exist, VLAN 9 didn't exist, and a whole bunch of other VLANs, the switches are synchronizing to the device with the highest revision number. So as an example, if you added a switch to the topology from a test environment, so a switch was on your desk and you were adding and deleting VLANs, and you didn't set it to transparent mode and then to client mode before you added it to the topology, and you erased all the VLANs from that switch and forgot to set it to transparent mode and then to client mode before adding it, all the switches in your network would synchronize to that switch with the highest revision number, which now has no VLANs in the VLAN database, and the switches would simply delete all the VLANs from the VLAN database, and any ports not in VLAN 1 would become non-operational. So in this simple example, I'm just showing you with one VLAN being removed. But you can imagine in an enterprise if you had lost all your VLANs. And this has happened to people. When the VLANs have been removed from the VLAN database, such as in this example, the entire network can be brought down. So router 1 is still not able to ping router 2. Have the VLANs been synchronized? So on switch 3, notice the pings have just started. So on switch 3, show VLAN brief. VLAN 10 has been learnt. Gigabit 01 is in VLAN 10. Switch 4, show VLAN brief. That's been learnt. And I don't know if you can hear that, but my PC CPU has spiked. So it's probably because it's having to settle down that the pings are failing. On a real physical switch, it probably would have continued succeeding. But here we're having a problem at the moment. While things sort themselves out, which may be spanning tree. Shows spanning tree. Ports are forwarding at the moment. But that's something to be aware of. Now notice previously gigabit 00 was forwarding, and now gigabit 02 is forwarding. So spanning tree is still working out what's going on. And this is probably an issue now with GNS3 rather than with the protocols. But be aware, if you remove a VLAN from the VLAN database, it's going to cause problems on your network if ports are configured in that VLAN.